In this video, I'll be quickly demonstrating a work-in-progress project. It's a Renishaw encoder-based translation stage with 50 nanometer measurement resolution driven by a NEMA 8 stepper motor. Here you can see the test mode in my control app. The app is pretty early and mostly vibe coded for now, since most of my time has been focused on bringing up the hardware. For this test, I'm mostly just verifying that the encoder signal is coming through properly and seeing how the stage behaves while it's stationary. It's an early bring up test to check the feedback, noise, and any small drift before I move further into the closed loop control. For the rest of the video, I'll show some CAD modeling time lapses along with the assembly process for the encoded translation stage. I'll be making more videos on this translation stage as it develops, as well as other optical precision stages that will be part of my microscope setup. First steps here, which is pretty exciting for me. Later on, I'll be adding sapphire pads and a stainless steel coupling nut to clean up the mechanical interface. I want to quickly pop in here and explain these small extrudes around the through holes. Since the holes are printed sideways, the sharper edges help the slicer make them cleaner and more circular. As you can probably hear, I'm stressing a bit while assembling the encoder for the first time. These components are pretty expensive, and since this is the first bring up, I'm also slightly worried about whether everything will actually work once it's together, but thankfully it did. As you can see here, the light now stays green throughout the full travel range of the stage, which means the encoder is happy and the stage is ready to go.